This video is about subtracting real numbers and variable terms. We're in the context of beginning or elementary algebra, and we just discussed adding real numbers and variable terms. Well, addition and subtraction are so closely related that you won't find too much difference in this. So we're just kind of reviewing the arithmetic involved that we're going to need for building our algebra skills. Our first example is -4/9 minus, parenthesis, -1/9. And so we just want to simplify or combine terms in these cases. And you'll notice that we have a couple fractions involved and a case of double negatives. So let's start by just rewriting this problem as -4/9. We're just copying that first term down. But then the minus negative, the double negative after it, we'll turn that into a plus, which would then be +1/9. So it's the case, again, where we have different signs that we're putting together, adding or subtracting. And so we have -4/9 plus 1/9. We do the arithmetic across the top since we have a common denominator already in place. -4 or -4 plus 1 would be a -3. So we could call this -3/9. Of course, that's reducible. You could divide the numerator and denominator each by 3 there to get an ultimate answer of -1/3. Our second example starts as -6 minus -3 plus 8 minus 11. So the -6 minus, and then it's parenthesis with a -3 close parenthesis. That's creating a double negative there. Let's go ahead and start by just rewriting this and fixing the double negative as we do. So we'll make this -6 plus 3 instead of the minus -3, and then plus 8, and then minus 11 to go all the way to the end. Then we'll have to recall our order of operations for addition and subtraction. They're in the same group. You just go left to right, and that order does matter. So we'll have to go one pair at a time from left to right. We'll take the first pair, the -6 plus 3, and combine those to get a -3 ultimate combination there. But then copy down the plus 8 and minus 11, which follow. And then we just kind of start over, taking one pair at a time. The next pair in front would be the -3, now plus 8. Combine those and we'll get a +5. And then we can bring down the -11 that lingers at the end there. For a last step of 5 minus 11, again, remember, do bigger minus smaller, keeping the sign of the bigger. So 11 minus 5 is 6, but the 11 is the bigger one that was negative in front of it, so we make this -6 for our overall answer. Let's try a third example. This one starts with some absolute value expressions. Let me read through it. We have the absolute value of, so open absolute value here, and then 24 minus -16, close absolute value. So there's a double negative inside the absolute value, and we should start by simplifying that. So I'm going to copy down the absolute value, and inside I'm going to write it as 24 plus 16. So the minus -16 is now just a plus 16. Moving on, we'll keep the negative that follows it, and then we have a absolute value of -5. Well, as we've already discussed with absolute value, it represents the distance between a number and 0 on the number line. And so -5 is 5 units away from 0, which means the absolute value of -5 is actually just +5. So that +5 replaces the entire absolute value of -5. It still has the minus sign in front of it that was already there. We only took away the minus sign that was in front of the 5 inside the absolute value. Moving on, we'll write this as minus, and then in parentheses at the end we have -31 plus 2. Well, we can do the arithmetic there of 31 minus 2, but then making the result negative, which would ultimately be -29. So, if I could read after this first step, since there's so much going on, we have absolute value of 24 plus 16, close the absolute value, then -5, minus, open parenthesis, -29, close parenthesis. So we'll go another step, and inside the absolute value we have 24 plus 16. We can just add those up, which would give us a value of 40. And that's inside the absolute value, so I'm going to keep the absolute value surrounding the 40, just for now to be super clear. And then moving on, we have a minus 5. Next, we'll turn our minus negative 29 from above into a plus 29, the double negative turning positive there. And then if we restart once again, the absolute value of 40 is just 40. So we'll have 40 minus 5 plus 29. Be careful, the order does matter. We have to do order of operations, which would include left to right for addition and subtraction. We're going to do the left pair here of 40 minus 5 to get 35, bring down the plus 29 after it, and end up with 35 plus 29, which is a total of 64 as a result for that. Our last example in this topic here is going to be to write using algebra. We're starting with a word, phrase, or sentence, and we're going to convert it to math symbols. The phrase reads, here we go, the quotient of negative 7 and a number subtracted from the quotient of negative 12 and the number. So we have to recognize the terminology in this problem that correlates directly to math operations and write those operations or variables and numbers in the correct orientation. When we see words like quotient, which we do see twice in this problem, quotient refers to division. And so when we see the quotient of, that can be translated into a fraction representing the division. When we see, as it starts here, the quotient of negative 7 and a number, we could put that as negative 7 over x, x being the number. And then that is subtracted from, now that's a very tricky, important phrase. Subtracted from, of course, deals with subtraction, but the order of subtraction matters, unlike addition. And so we have to be careful about what it's being ordered as. When it says subtracted from, that means what we just wrote is being subtracted after something else. Okay, so I'm going to put, we already wrote negative 7 over x. I'm going to put that now after a minus sign, and then before it will come whatever it's being subtracted from. Well, we're subtracting it from the quotient of, okay, another quotient, so I'm going to put another fraction in front of that subtraction sign. That second quotient reads the quotient of negative 12 and the number. Well, the number we already wrote as x, and so we can write negative 12 over x. All right, so again, the order matters when you're doing subtraction especially, and you'll see phrases like subtracted from, or sometimes less than, or the difference of. Every one of those phrases has a specific order, and they're not all the same, so make sure to read up and practice on those. I'm just illustrating in this example that subtracted from means you actually reverse the order in which you're seeing things. Right, we had the negative 7 quotient subtracted from the negative 12 quotient, and notice the negative 7 quotient came after, or second. So be careful on the order. Now, we can simplify this even further by rewriting it again as negative 12 over x, and then the double negative we're seeing in the second part of this, where it's minus negative 7 over x, those two negatives can turn positive so that it's really plus 7 over x. Now we see a common denominator of just x, and so we can add across the top. Negative 12 plus 7 would be a negative 5, using those subtraction and addition rules with signed numbers, and that's all over the common denominator of x, so that negative 5 over x is our final answer.